It's 15.
It is clearly 13.
What are you talking about? It's 15.
Look at the question. It's 13, you... No.
It's 15. I'm sure about this. It's 15.
No, it's not. It's not. It is 13.
You want something from me?
Yeah, go for it.
Come.
Go for it.
From me?
Go for it.
Oh.
Go for it. Go for it. Go
You
for
want?
it. Go for it.
What do you want? Oh. Oh.
You know for a fact. You know for a
15.
fact.
What are you talking about?
You watch it.
Guys, cool it off. What's going on?
You have a math problem.
A maths problem.
Yeah, I think it's 15.
It's definitely 13.
A maths problem? Get me Paul the number theorist.
The pause signal. Someone needs me.
Paul the number theorist?
What seems to be the problem?
We've got a maths problem.
How many different 5-digit numbers are there whose digits add up to 43? I think it's 13.
It's definitely 15.
The maximum possible 5-digit number you could have would be 99,999. And you can see the sum of these digits, the 5 nines, adds up to 45. Our target sum of the digits was 43. So if we do 45, take away 43, we're left with 2. 2 is the number that we need to take away from these digits to be left with a 5-digit number that would sum to 43. And the way we can split 2 up is we can either just take 2 away from one of these integers, or we can take 1 from one of them and 1 from another one, and that will leave us with a set of different possible digits to generate the 5-digit numbers. If we go down the first route of taking away 2 from just one of these digits, we get left with the digits 9, 9, 9, 9 and 7. And then there's 5 possible ways of arranging these digits that will get us 5 different 5-digit numbers which all still sum to 43. We could have the 7 there, 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 there or there. And the way we decided on the number of combinations is using the combination formula, choosing one position from the 5 positions, and that just further backs up the fact that we have 5 possible numbers. The second route you could take is taking 1 away from one of these digits and then 1 away from a different one of these digits. That leaves you with the digits 9, 9, 9, 8, 8. Now the positions of the digits that are important for generating the 5-digit numbers are the 2 8s. And we choose these positions, for example, 2 8s at the end, or an 8 and an 8, and there'll be a maximum of 10 different 5-digit numbers made up of these 5 digits. And we generate that by choosing 2 positions from 5 positions. So if we use the combination formula, that's 10 different options. Right, so now you've got case A, where we took 2 from one of the digits, which gave us 5, as 5 choose 1. And then we add that to case 2, where you had the digits 9, 9, 9, 8 and 8, and that gives us 10. So the total possible number of 5-digit numbers whose digits sum to 43 is 5 plus 10, which is 15.
The answer's 15.
Yes! But how many different 5-digit numbers are there whose digits sum to 39?
Now we want to find the total of 5-digit numbers whose digits sum to 39. We're going to approach this problem in the same way as the last one. If we do 45 take away 39, we've got 6. So we know we've got to take away 6 from these digits in some possible ways. Now there are a lot more cases to deal with. Right, now you can see 6 can be split up into the natural numbers in 11 different ways. It could just be 6, or it could be 6 lots of 1, or carrying on through this diagram. Now since we only have 5 digits to take away from, we can exclude this case because we can't take 1 away from 6 digits that we don't have. This leaves us with 10 possible cases to check. All these cases will have different digits whose digits will still sum to 39. One of the cases we can easily deal with is just taking away 6 from one of the digits. Now we can see 9 plus 9 plus 9 plus 9 plus 3 will add up to 39 like we need. And this is very similar to the case we had before where we had the digits 9, 9, 9, 9 and 7. So we're just going to use the same choice formula, one chosen from 5 positions, which will give us 5 different 5-digit numbers generated from these digits, whose sum is 39. Another case worth noting is when we take 5 away from one of the digits, and then 1 away from another one of the digits. This will leave us with the digits 9, 9, 9, 8 and 4. Now, unlike in the example from the previous question, where we had 5 choose 2 representing all the possible numbers, since the 8 and 4 are different digits, now the order these digits are in matters enormously to the 5-digit number that we're generating. So you can see if we had 99984, that would be a different 5-digit number than if we had 9994 then 8. So the way we deal with this is we've got 10 possible ways of choosing the positions of these two, and then we're going to have to multiply it by the ways we can choose the position for these two to be in. We can either have the 4 before the 8 or the 8 before the 4. So that's 2 positions being chosen from 5 and then 1 position being chosen from 2, which gives us a total of 20 possible 5-digit numbers whose digits will sum to 39 from these digits. Now, the only case with a different method than the ones we've previously covered is when we take 3 from one digit, 2 from another digit and 1 from a final digit. This will leave us with the digits 9, 9, 8, 7 and 6. Now we can see we've got 3 digits that are all different. So first of all, like before, we've got to choose a position for these 3 digits amongst the 5 digits, and we represent that with 3 positions chosen from 5. But then we have to choose a position for, say, the 8 amongst the 7 and the 6. So we've got to choose a position for one of the digits amongst the 3. And then because these 2 digits are different again, we're going to have to choose a position for one of those digits amongst the other 2. So this leaves us with 5 choose 3, multiplied by 3 choose 1, multiplied by 2 choose 1. So that will give us all the possible different 5-digit numbers that are made up from these 5 digits that will sum to 39, and that's 60 different possible numbers. Now, this table has got all the possible cases that we had before, and the digits we're left with, and then the combinations that we have to use to get the totals. These are the totals, and then the total possible number of 5-digit numbers whose digits sum to 39 is 210. I'll let you just process this.
The answer's 210.
Archimedes knickers! Paul, you've done it again!
All in a day's work for Paul the Number Theorist.
Who was that?
No idea, let's get a pint.